I'm Dzun binti Jimat from International Islamic University Malaysia is presenting Elaeis Finecell nanocellulose from empty fruit bunches, which is non-toxic, lightweight, renewable and versatile nanomaterial that extracted via sustainable and green extraction process. Existing technology to fractionate the composition of empty fruit bunches, which are lignin, hemicellulose, and cellulose, are using concentrated acids. This method may raise some problems such as longer time treatment process, hazardous to human and environment, and more complicated post-process. This method is also may cause inevitable equipment corrosion and environmental pollution that restrict the application of this method in the industrial scale. Here is the good news. We propose sustainable and green extraction process using deep eutectic solvent to fractionate empty fruit bunches before further fibrillating into nanocellulose. DES is a new class of ionic liquid consists of at least one hydrogen bond donor and one hydrogen bond acceptor, results in liquid mixture with unusual low melting points. DES are alternative comparable to ionic liquid at lower cost and seem significant in separation of lignocellulosic materials for extraction of cellulose. Specifically, in this extraction process, we use choline chloride and oxalic acid dehydrates to extract cellulose from empty fruit bunches. This Elaeis Finecell nanocellulose is produced using sustainable and green extraction process is in line with Maqasid Sharia in terms of protection life. Additionally, the creation of this green and versatile nanomaterial is also correspond well with Sustainable Development Goal SDG 3, 6, 14, 15, and 9. There are three existing methods used, however, all give negative impact to the environment. Alternative green treatment process that we propose can be used effectively in treating lignocellulosic material, in extracting cellulose and facilitating post-process in producing nanocellulose. DES are cheaper than ionic liquid, water neutral, low or non-toxic, and often biodegradable. The usage of this green chemical will sustain the cost incurred in the treatment process of the lignocellulosic material in extracting the cellulose. We screen few combination of deep eutectic solvent and the best DES combination, which gave the higher yield of nanocellulose, is used for optimization study. Ratio of the solid material to DES temperature and reaction time of the extraction process were optimized. We managed to obtain the optimal yield and improve the crystallinity index and aspect ratio of the produced nanocellulose. In our current project, we use Elaeis Finecell nanocellulose as reinforced nanomaterial in making hydrogel polyvinyl alcohol and polyethylene glycol PEG. Use nanocellulose Elaeis Finecell in fabricating our chemically modified polyvinyl alcohol forms as oil absorbent. Another application of this Elaeis Finecell, we reinforce it into magnetic carbon nanotube form as oil absorbent. Many manufacturers of nanocellulose in the market globally. However, only few of them disclose the extraction method of cellulose. They are Zoib Nano, a pioneer nanocellulose commercialization in Malaysia, the Grain Bio with their product Bio Plus nanocellulose based in USA, the Nanocellulose Lab based in Canada, and the Current Cellulose Company, which is a Scottish-based company in UK. All of them produce nanocellulose from different raw materials, but they are using chemicals that are harmful to environment and not sustainable. Our target customers are IPTA and IPTS research institutes and industrial players in composite and packaging industries. Bio-based nanocellulose product can be produced using acceptable conversion and extraction techniques, which are projected to expand consumer demand over the forecast period due to favorable government initiative to facilitate the production and usage of bio-based products. The rising demand for bio-based products among end user is the key factor that helps in boosting the biochemical market 16% increase in 2025. Globally, packaging is the highest sector that consumes plastic compared to other sectors in industry. It composes 34%. Thus, it is a good opportunity for Elaeis Finecell nanocellulose to be used as a reinforced filler in manufacturing of renewable and degradable plastic.